Okay, so let's make a start. I'm hoping you can all see the screen. So this presentation is about how to become a data professional. Either you're thinking about starting afresh, so you're a graduate or new to the job market, or you're thinking about switching careers. So hopefully in this presentation, you'll get an understanding of what it takes to enter the data space as a professional. Okay, so who am I? So my name is Shawful Islam, Dr. Shawful Islam. I am currently, have three roles currently. I'm the Chief Executive Officer and co-founder of a data consultancy called BData. BData does everything from data strategy, data analytics, data engineering, data science, and AI. I've recently just co-founded a product called Lease Drop. It's an AI-powered lease extraction product. Do check it out. It's leasedrop.ai. You upload your leases, if you've got commercial property or something, and it picks out clauses that you need to know about. And then finally, I'm managing director and founder of Subatomic Analytics. This is where I do a lot of my personal consulting from. So I do a lot of consulting around advising, especially CEOs of big companies, on how to use data. So I work a lot with sort of senior execs in ensuring that they're leveraging data for the most advantage for their organization. I do hold other positions as well. So I'm an advisor to a cybersecurity, AI-powered cybersecurity platform called Outthink. I'm also an advisor to a product that looks at health and safety in the workplace, powered by AI and data. Beam is a mental health or a resilience app. I'm an analytics advisor there. And then I'm also an advisor to Data Ravens, which operates in the medical space in terms of data utilization. Previously, I had another company called Stream Intelligence, which I ran out of London and Jakarta, Indonesia. And then I held corporate roles at Wonderman. I was managing partner there, so I sat on the board, same with Adam and Eve. And then I was head of business intelligence and customer data strategy at ITV. Okay, so there's sort of some of the roles. My background is actually in psychology. So I actually hold a PhD in psychology, hence the doctor title. I also have a master's in health psychology and an undergraduate in psychology. And the reason I got into data is because in the late 90s, I wanted to understand and predict why children have accidents. It was part of my PhD. And in order to do that, I built what now is considered machine learning. Back then, we just called it advanced analytics, but it was ultimately a machine learning model to predict why children have accidents. Okay. My early career, at the moment I've co-founded and I run consultancies, but I've also been a lecturer, a researcher, a data strategist, CRM and loyalty strategist, and analyst. So I've worked across all of these brands. Just a sample of some of the brands that I have worked for or worked with, and in various roles. And I've also analyzed a whole host of data, everything from product and pricing data to customer and people data to digital and social data and IoT, Internet of Things data, the things that come from smart devices. I've analyzed all of that data as well. So let's get to the crux of the presentation. So what does a data professional do? Now, historically, a data professional would have typically been someone who brings a structured approach to solving problems using data while maintaining the curiosity to ask the why behind the numbers. Okay, so these would have included roles like data analyst, business intelligence developer, database administrator, data architect, or modeler. And we're talking 25, 30 years ago. These were sort of a limited set of roles that were in the data space. However, what's happened now is that the data landscape has drastically changed, especially in the last 2 decades, because of big data, machine learning, AI, and ethics. And some of what has changed is the explosion of unstructured data. So historically, a lot of data that was collected by organizations was structured. Now, a lot of the data that's collected digitally is unstructured, everything from social media posts to documents to chat on Teams, on Slack. All of that data is now accessible and can be analyzed. The other thing that's happened that's allowed this migration is from on-premise to cloud. So essentially, 3 decades ago, all data was stored in like physical servers in someone's building, in a company's building. Now it's cloud first, so it's on data centers, and organizations now just rent the servers rather than have them on their own premises and maintaining them. There's been a rise of real-time versus batch data. So a lot of data now is streamed, and so people are using that data to inform real-time decision making. The use of APIs, so the ability to connect to data sources, and I'll talk about it later in how it looks like. The democratization and self-service of BI. So now business users are using more self-reporting. Before, business intelligence developers would have done the report for them. Now businesses themselves, the business user, so whether you're in marketing or finance or in product, you can run reports yourself because of the way democratization of data has happened. And then obviously now the recent shift from analytics to generative AI. So data is now used to actually formulate content and text rather than just analyze numbers. So one of the reasons these new roles in data have emerged and have flourished is because of the modern data landscape. Now, if we talk from left to right, what you end up now is that there are many data sources now, okay, and I've just listed a sample, but we've got things like smart cars, we've got smart watches, we've got CCTV. There's so many data sources now, and what happens is that those data sources are now easy to ingest. So they've been designed so that you can extract the data. Historically, systems were very closed. It was very hard to get access to the data. Now they're designed for that data to be accessible, and so things like data pipelines would have been built to address those issues. So things like data pipelines here. You then had then the next thing that happened was cloud platforms. So you had this chunk of work here. So you had cloud platforms where data was easily ingested and stored, and you would have heard things like Microsoft Azure, you would have heard of things like Amazon AWS, GCP, Google Cloud Platform, and then that data would then either have been stored in traditional data warehousing or would have been stored in data lakes. Okay, so so that's where that data is then accessible, and then what you end up with is data being stored into actual structured data. Not all data that's analyzed is structured, but you still need an element of structured data. And then finally, you had query tools, things that would query the data. So things like Python and R can not only query structured data, they can also query unstructured data. You've got Power BI, Tableau that do need very structured data. MySQL, SQL Server is very structured. But then you've got data feeding straight into AI systems, right? So you've got the ability for data to be fed from these systems straight into things like websites. So things like recommendation engines, things like personalization, they are powered by data. So whenever you open up your social media feed, you're getting some personalized recommendation that's being data fed to you. And more recently, we've now got this AI component of data where the raw source of data is needed for these generative and agentic AI systems to operate. Okay, so that's like the modern data platform. It's very simplified. It's much more complicated. There's more technologies involved. But the reason I wanted to show you this is because then you can see where roles fit in. So the first type of roles in data are what are probably the builders, right? They're the people who build the infrastructure. The most famous of those is the data engineer. Okay, so you've got the data engineer role here, and this is the role that will take data from these source systems and pump them into a storage area and then transport them into either a data warehouse, data lake, and so forth. You've then got things like data architect. They design these. These roles have transformed from solutions architect or enterprise architect to be data specific. So, you have a lot of people who may not be able to be good at coding, but they can design these systems. So they're called data architects. So if you've got a mind for designing, if you've got a mind where you can create solutions based on how things should flow, data should flow, data architect's a good role. Data engineer is very much a coding role. It requires people to be able to create data pipelines, ingest the data, transform it, load it, and move it on. Then you've got database administrators, people who manage these databases, whether it's a data warehouse, data lake, or a database table. You've got people who need to manage those, because you may analyze data on your PC and it may be a few million rows or a few thousand rows. A lot of these systems hold billions, if not trillions, of rows of data. So you need to make sure that they are performing, at the best. And secondly, they also contain very sensitive information. So therefore, you need to make sure that the security of those databases are intact. So that's where the database administrator coming in. And then a recent role that's come along is called analytics engineer. And what the analytics engineer does is he takes the raw data and transforms it into the type of tables and structures that are needed by the business to answer questions. Okay, so they sort of translate raw data into structured data that the business can use to answer questions, and that includes things like analysis, cleaning, and transformation. So these are like the engineering. Now, to get into these spaces, you generally need to understand how infrastructure and systems work. Okay, so you need to have that kind of mindset. So if you're very good at building PCs, for example, you're very good at setting up servers, these roles will be really good for you because that's what you're doing ultimately. So even at a minor level, if you are setting up a mesh at home, you'll get an idea of how data moves along. Again, some of these roles I'll talk in more detail later on, but I'm just giving you a flavor for now. Then you've got the interpreters, the analysts and insight people, okay? And the kind of people you've got data analysts, and these are the people who basically the business asks to answer specific questions. So they'll be asked things like, have my sales gone up? I ran a campaign, what happened? Can you tell me if I do this promotion or if I build this product, what will happen? So these data analysts are very good at using things like SQL to query the data, typically structured data, to answer very specific business questions. And so and again, I'll talk more about these roles, some of these roles later on, but these are the guys who pretty much will be the most common sort of analysts that you'd be coming up against. The next type of analyst is what's called business intelligence analysts. And these are actually legacy roles where these are people who build analysis that's used time and time again. So data analysts generally will build or run reports or queries or an analysis that's one-off. Business intelligence people will they'll build dashboards, they'll look at long-term trends, and they're usually supplying they're supplying insights and data to the business on a very regular basis. Okay, so these guys, and like I said, this is a legacy role. This actually used to exist before this big surge in data and big data. Another common role is actually statistician, and though you don't find many of these in the commercial sector, they're very big in the government, academia, private research, like pharmaceutical companies. So they provide very rigorous mathematical models to ensure the data is represented accurate. So you can imagine why in government and medicine these people are quite important, because they need to show how it would perform or how it would work with a large population and based on a sample. So these people are very good at statistics. They're very good at probability and sort of sampling and that kind of stuff. And then you've got this quant analysis, and these people are very exclusive mainly to finance sector. So if you come out with like a really good mathematics, physics or something degree from one of the top universities, you'll find that you're usually headhunted for quant roles. And these are people who work in finance and private agencies looking at markets and predicting movements. So stock markets, shares, private equity, that kind of stuff. So they're quant analysis. They're generally specific to financial markets and private sort of equity funding type areas. So those are the people who generally you'll come across who use the data. Then you have the innovators, the people who invent stuff with the data. The first one is the data scientist. Now, the data scientist, as the name suggests, is a scientist. So what they do is they will go into the data. There's two ways they analyze the data. One is they're given a hypothesis. So they might be told things like, we believe that if we gave people a 10% discount, they're more likely to buy than if we don't. So they'll go off and run analysis and run experiments to see what will happen, or they will go into the data and they will find patterns that they will then make sense of to the business and identify new opportunities. So they're sort of like researchers with data. That's why the term data scientist exists in their title. So they're actually going in, discovering new things and building models to predict or to understand those things. The next one is a machine learning engineer. Now, what these people do is what used to happen is the data scientists, they're very research oriented. So they build models that aren't able to be used in what we call production environment. So, for example, your website or your app or your smartwatch is a production environment. It's an environment that what we call is production ready, that the consumer can use. The models that data scientists build are not production ready. So these machine learning engineers take what the data scientists have done generally and make them production ready software. So things like Netflix's recommendation engine or a fraud detection system is a production level product that these data engineers deploy. So basically what that means is that they build all of the infrastructure and architecture to make sure that the recommendation engine on Netflix just runs by itself. Okay, there's no one behind the scenes refreshing, going, oh, so and so's come, let me refresh their model. These are automated processes that the engineers build, and it just keeps running until they need to change it for whatever reason. And then finally, the last few years has seen the rise of AI researchers, and these are pretty much data scientists, but with a specific focus on AI. And what they do is they push the boundaries of what can be done with data. So, for example, we've seen now with things like ChatGPT and Claude and Gemini that you can ask it to write your essay, right? You can write articles, you can ask it to draw images. So these guys are in that space. They discover new ways of doing things with data, and so they're AI researchers. Okay, so those are sort of the people who are pushing the boundaries of innovation. And again, to get into one of these roles, you do need a specific type of expertise to do that. And again, I'll talk about a bit of that later. And then finally, these roles have always some of these roles haven't existed before because people didn't take data seriously. But the one that did exist before was the data governance manager in various forms. So there was always someone in an organization that was saying, how do we use data properly? Make sure the standards and stuff. This has become now more and more important. And one of the reasons it's become more and more important is because data is used throughout the organization. Before, it was very much a tech reporting type activity. Now it's actually used in, like I said, fraud detection, or actually a selection of certain products and services. So if you went online and you wanted to see if you're eligible for a insurance, for example, and an algorithm is determining whether you're eligible for the insurance, and now if that algorithm is not compliant or is not free of bias, then what happens is that people get excluded. And this is like in the medical space, for example, right? If you've got algorithms that are detecting cancer and stuff, but they're not picking up it in certain groups of people, then it becomes a big risk. So these people are the stewards. They manage and they oversee all of that data to make sure that it's good quality, it's being used appropriately, and used correctly. And then in the last 10 years, the data privacy compliance office has come along. So there's been lots of laws now that have been passed. And if you work in a larger organization, then what you find is that you need someone who's making sure that the innovators, the people I showed you in the previous slide, aren't misusing the data. They're not creating things that might jeopardize or infringe on people's privacy. Okay, so if you've been to a website and you've given them your personal information, if they haven't asked for permission to use that personal information, they shouldn't be using it. Okay, so these data privacy compliance officers make sure this happens. And then in the last, 10, 15 years, the chief data officer role has come about. It's basically an executive level role that manages and oversees all of data. It's one of those roles that a lot of large organizations have got, and it can range from people who are very strategic to people who are very executional, very technical, and it's one of those roles that's meant to own all of data. Okay, so those are roughly the types of roles, and there's some in between. You'll get certain types of roles that emerge, but these are roughly the type of roles. So let's deep dive into some of the common entry level roles, because obviously some of the other roles, like chief data officer, you need to be qualified to get into it. So I want to talk about some of the roles that you could just go into it after graduating, or if you're switching careers. So the first role you could actually go into instead of either straight away or from graduation or from college, or switching careers, is data engineer. And what the data engineer does, if you look at their job description roughly, is they do pipeline construction. So they build, maintain automated, what we call extract, transform, load, or extract, load, transform processes. So basically they move data from one place to another. That's their job. So but they will create what we call data pipelines to move data from one place to another. They then do data integration. So they connect those data sources together using APIs, using connectors, internal databases, and put it in one place. So like I said in the diagram before, they would put it usually in a cloud infrastructure or a data lake or a data warehouse or a combination of something called a data lake house. So they try and bring it all together. They also make sure that it's reliable, because what they don't want to do is look at these pipelines. So what they do is they build pipelines and integrations that just run. Okay, so they don't crash when there's lots of traffic. These pipelines just keep running. They're bringing in data all the time, and you can just sort of leave it to it. And they'll only get involved if things need to change or they need to add new data sources. They also, a lot of the time, they spend cleaning data, writing code to handle missing values, duplicates, and that kind of stuff. So they're trying to make sure that the basic data cleansing is happening. And there's two reasons for that. One is obviously to make sure that the data goes through is useful. The second thing is to get rid of redundant data that's just going to take up space that you don't necessarily need. And then finally, they do a lot of optimization. They tune databases to ensure queries run in seconds rather than minutes. Because like I said, a lot of these systems in the commercial space are trillions of rows of data, and so they need to make sure that these are optimized to run quickly. So that's the typical job description of a data engineer. And what you need in order to be a data engineer is advanced SQL and Python skills. So SQL is structured query language. It's a language that's used to query databases, and then Python, which is a generic language that can, not only can you build applications in that, but you can also analyze any type of data, structured, unstructured, so forth. Okay. You also need to have an understanding of JSON and APIs and connector technologies, because you're bringing in data from different places. You need to understand relational modeling, because when you bring data together, it's not always like you see in Excel. You have to connect those data sets and create some kind of normalization and reduce redundancy. Redundancy is basically duplication. So you wouldn't duplicate data. You'd design the relational modeling to ensure that there's no duplication of data. You've also got dimensional modeling, so mastering what we call star schemas, what are fact and what are dimension tables. So, what describes something and what is a metric for something, you would be building that. They also need to understand the difference between data warehouse, structured like Snowflake, data lake, or a lake house, hybrid of both, because that will determine where they put the data, because certain data would be best suited for certain places. And one of the reasons you need to be very good at this is because it costs a lot of money. If people talk about the cloud being cheap, it is cheap when you've only got a few million rows of data. When you get into the billions and trillions of rows of data, it becomes very, very expensive. So they need to have a knowledge of a cloud platform. It can be one. You just need to pick one. They're all pretty much the same. They operate in a very similar way. You can also transfer your skills from one to another. They're very common in how they operate. Knowing how to move files into an S3 bucket and a trigger function, so basically moving things into a place. They need to have orchestration tools, so understand orchestration tools like Apache Airflow or Dagster. What these are basically are tools that allow you to sequence events, because when you've got data, it has to come in a certain order. You can't just dump everything. There's a sequence of events that needs to happen, and these tools allow that orchestration. Then you need to be able to do transformation tools like dbt, which basically takes the data in the form that you get it and transforms it into tables and databases that the business can use. And then obviously optimization of tuning databases to ensure queries run in seconds rather than minutes. Now, the kind of person that will be suited for this role is if you've got a computer science background, or if you've got some kind of background where you did a lot of coding, okay? And also the other stuff, things like understanding cloud, understanding orchestration tools, that's more of a personal interest, right? If you have coding skills and you were going to build yourself a website, you would have a natural interest in understanding cloud technologies, because you need cloud technologies nowadays to do a lot of sort of website hosting and even database hosting. So, you'll be someone who's from a computer science background or a technical background, like an engineering background, who has, or in their course or in their experience, have built or have developed very advanced SQL and Python knowledge. Now, if you have an advanced knowledge of another programming language, it's very easy to transfer that over to SQL and Python. You could potentially do a very short course and you'd be very good at it. But you need to have that mindset of coding, very good structure in your head, very analytical, very good at sequencing events. Okay, so you need to be the kind of person who can organize their mind into thinking about things in a logical way. Okay, so those are sort of data engineers. So if you are going to go into that space, then you need to come from a very technical background if you want the best chance of getting into that space. Then the next role that's very common for junior people to enter, graduates and people who want to change career, is a data analyst. And this is actually one of the most common roles that people go into. And what these roles generally do is things like ad hoc reporting, right? So they will answer specific business questions. For example, why did sales drop today? What happened because it rained yesterday, or that kind of stuff. So they just answer questions that the business have. They're also very good at data visualization. So one of their roles is communicating what they found in an easy to understand way. And one of the ways they will do that is through creating graphs and charts that are suitable for the data that they're presenting. Okay, so they become very good at understanding what data they need to do where. They need to identify trends, because a lot of the time data analysts are really helping the business understand what happened in the past and can we help it to explain what we might do in the future or what might happen in the future. So if a business has, for example, has run a Black Friday, then they might say, okay, we've run 3 Black Fridays. What do you think this Black Friday is going to do for us? And the analyst is able to then identify trends and be able to tell them how it's going to perform in the future. They also do a lot of data validation. So the data analysts are very close to the business, so they know what the numbers should look like. So they make sure that any numbers that comes in is of good quality. Data analysts, if they do not double check everything and pay attention to the detail, then it's not going to work. You need to be the kind of person who absolutely cares that the decimal place is in the right place, that the dates are correct, that the labeling is correct. You need to be obsessed about that kind of stuff. And the other thing is data analysts work across the business. So they need to be very good at collaborating with different departments to make sure that they understand what is important for that business. Now, what you need if you want to be a data analyst is that you need some level of knowledge of SQL, intermediate. This is the kind of stuff that you can either do in your degree, if you're running a computer science degree, or any engineering degree, actually, or maths degree. You can easily do some kind of SQL. But you can actually, even if it's not in your degree, if you're so for example, I entered the world as a data analyst. My background is psychology. I knew the statistics stuff, so the latter part here, the statistics and analytical knowledge, but I learned this on the job. But you can easily learn this now from courses. There are so many courses, YouTube courses, that you can learn this from, so it's very easy to pick up SQL. This is very important still. People underestimate, but you need to have very, very good Excel or Google Sheet skill, like advanced. And I'm not talking about just writing sum or VLOOKUPs. I'm talking about very, very advanced Excel and Google Sheet skills. You need to be able to use some kind of visualization tool. Now, you don't need to be an expert at it, but you need to know how it works. So Power BI, Tableau are 2 of the most common ones. You at least need to know how it works. Now, if you're at university, you might have free license to Power BI. If I were you, I'd play around with it. Or if you're in a company that has access to it, play around with it. You can actually import local data, i.e. local data from your PC into Power BI and play around with it. You just need to know enough to build a dashboard or a report, okay? And the reason for that is the data analyst is not going to be the one who's going to be asked to build sort of corporate-wide reports. They're going to be asked to build one-off type reports, okay? So you just need to be good enough to use it. So basically, if you got hired for this a data analyst role, no one's going to be showing you how to use Power BI. You're going to have to know how to use it in the beginning, and then you'll learn on the job. But the big thing about being a data analyst is statistical and analytical knowledge. You need to have good descriptive statistics. If you are not good at statistics, and this doesn't mean that you have to do a math degree. I did a psychology degree. Psychology is full of statistics, okay? And a lot of other sociology, a lot of other social sciences are full of statistics. So you don't have to be from a maths or a stats background. You could come in with a social science degree and become a data analyst. The rest of these things, like I said, you can easily pick up. But this kind of stuff, it helps if you're taught it formally. So learning statistics formally is really important. You can try and teach yourself, but actually I've found, and all the people that I've hired, is that you're only good if you've been taught it in your part of your degree or part of your courses, because the way it's taught means that you get to understand its relevance and application. So inferential statistics is simple stuff like correlation, A/B testing, that kind of stuff. You need to be good at data cleaning, okay? And you know to handle missile values. So if you do statistics, you know things like how to look for outliers, how to look for duplicate. You'll know about skew, how if data skews. You'll know if there's kurtosis in the data, all this kind of stuff. The other thing is you need to have domain knowledge, okay? You need to understand the business you're in. So as data analyst, you will have to if you're going to go and apply for a job, you need to know that job. Now, this is where I say, for example, if during your degree or during your studies, you were working in a retail store, even if it's a cashier or a shop front, that knowledge is invaluable. Do not underestimate that knowledge. If you've worked in retail, you know how it works. You know how the tills work. You know what's collected. You know when you scan the barcode, what data comes up on the point of sale on the till. Okay, that knowledge is very valuable. So don't think that any part-time job you do is not valuable for data analytics. So if you work in a hospital, for example, you work in a clinic, and then you apply for a job as a data analyst in a clinic, your knowledge about how a clinic operates or a hospital operates is actually very valuable. So do not discount that. So when you're doing your CV, if you're applying for a job in a domain that you have previously done a part-time job in during your studies, I would highlight that, okay? And then finally, one of the things that's very important to be a data analyst is curiosity and skepticism. Sometimes you will analyze the data and it will just be like, oh, okay, that's fine. But you've always got to have in the back of your mind, is this actually true? Does it make sense? Is the data source broken? Am I seeing an artifact of something, right? Sometimes the data doesn't lie, but it hides hidden truths, and you need to make sure that you can get to those hidden truths so you're not being misled by the analysis that you're doing. So data analyst is something you don't need like necessarily a maths or an engineering or a computer science degree to get in. You can get in through other ways, as long as the statistical stuff you've got a good grounding on. Domain and curiosity you build through your normal life, like your experience of living. And SQL, Excel, and visualization, you can easily do short courses and become proficient at it. I mean, I'll reinforce that at the end. A lot of people are doing this now, so don't think that just because you've done a certification, it's automatically going to get you a job. The job market's very competitive, and so you will need to really be good at it, and you'd need to be able to demonstrate that in a portfolio of how good you are. Then the other one that you can go in straight after graduation or switching careers is the business intelligence analyst role. And the job description is dashboard development. So building dashboards that displays or track company metrics, market benchmarking, so comparing internal performance against industry competitors or government standards. So you need to know, like how do I set targets and benchmark, self-service enablement. So basically you've got to build your dashboards and reports that are really easy to use so that a non-technical person in your company can use it, because you can't be the one running every report. You've got to be able to hand those reports over to other people who can then run their own report. The other thing is you've got to be very good at requirements gathering. You've got to be very good at understanding what is it that they want to see in the dashboard or report. If you're not good at listening, and if you're not good at translating what people say into a technical requirement, then you're going to struggle in this role. Because don't forget, when you built the dashboard, it doesn't talk. It's just the dashboard. It's got to be so intuitive that it captures everything that someone wants, and they should be able to make sense of it themselves. And then it always helps if you know how to do some automatic alerting. So very basic scripting where you might set targets and go, if it's below that target, give me an email to tell me that it's gone below, or text message me or something. Okay, so that's generally what a business intelligence analyst will do. And what the CV would include is you'd need to be very good at BI platforms. So you must be a very good Power user or Power BI or Tableau. This is not something that you're going to be doing in your degree. So this is something that you should either do a Microsoft certification, or a Tableau is now owned by Salesforce, so a Salesforce certification. But you need to be very good at this. There's no training on the job on this. Unless there'll be some elements where you learn on the job, but you need to go in from day one and build enterprise level dashboard. You need to know advanced SQL. That's a must. You need to know data modeling, because data modeling is very important to how fast the dashboards run. If you don't know how to model data, then you're going to be pulling in too much information and the dashboards will be very slow. So if I change a filter, the dashboards will be very, very slow in changing. So you need to understand how to do data modeling. Again, like I said, requirements gathering, you need to be able to translate business questions to technical specs. So if you're the kind of person that people tell you something and you're able to then technically do it, then you'll be very good at this, right? So if someone says, oh, good, look, I want to know how my company's performing, that's a very broad question. If you're able to take that and go, right, okay, what does performing mean? Does it mean sales? Does it mean more customers? If you're able to break it down like that and then build the dashboard, you'll be very good at that. Process mapping is good because you need to understand how data flows through the business, from a customer clicking on something to money landing in the bank, because that will help you build your dashboards and understand the metrics that are going. So, for example, if you are on, let's say you're an analyst for YouTube, how do you measure how many videos someone's watched? Because don't forget, when I press play on a video, I see ads first of all. So have I watched a video or have I just watched an ad? Okay, so you need to map that out. You need to go, when someone presses play on YouTube, they first see an ad. It might be one ad, might be 5 ads. Then they see the video. Then there might be mid-roll ad, or they might abandon the video halfway through, or even abandon it when the adverts are playing and go on to another video or terminate the whole session. So I need to be able to map that. So when I report the numbers, they match the reality of how people use it. Visual hierarchy is very good, or very important. And this is very good for people who may not be technically strong, but they have a very creative mindset. So sometimes you may not be brilliant at the Power BI. You can learn this stuff, like I said, do certification. But if you're very good at creatively representing information, then you'll be very good at this role. This role is very much about the creative way to take numbers and present it back to the business in a way that the business understands. So, even if I've hired people with design and fine arts background into these roles, okay, who were very technical, but they were very good at visualizing information. And then contextual reporting. So when you do a business intelligence role, as the name suggests, you need to understand what's happening. So this is where you would be able to know about wider data sources. Now, again, this kind of stuff you may not pick up in your degree necessarily, but there will be some degrees, like if you do economics, for example, you know that there are government data sets, you know that there are public data sets out there, and you should be able to have a knowledge that if I'm reporting on, let's say, seasonal sales, right, and I go up, is that good or bad? You might want to benchmark that against GDP, right? So you might want to say, okay, if GDP goes up, I expect sales to go up. If GDP goes down, so you've got to have that knowledge about how do I contextualize the reports that I'm doing. And then finally, presentation skills. It's not a big thing for a business intelligence analyst, but a lot of the time you'll be asked to come and present information from your dashboard. I just want to quickly just give a comparison between data analyst and BI analyst, which I talked about before. A data analyst will be basically cleaning, exploring data for insights, whereas a business intelligence analyst is usually building that it can happen on a repeated basis. So a data analyst might do, like here, output is a one-off presentation or report. For a business analyst, they're building something that's used time and time again. Okay, so one-off compared to repeated. Stakeholders for data analysts are usually departments or department heads. BI analysts usually go senior. These dashboards go all the way to the chief exec. Okay, so as a business intelligence analyst, you have higher exposure to the business than you do as a data analyst. Data analysts could be sitting in a team just doing their business. The CEO never knows about them. But if you're a BI analyst and you build dashboards, they go all the way to the top, all the way to the CEO of massive corporate organization. Key maths here, data analyst needs to know statistics and probability, which we talked about. As a BI analyst, you don't need to know that. You just need to know basic arithmetic and forecasting. And what I mean here is like creating ratios, creating percentages, because you need to sometimes, like I said, the representation of data is very important. So rather than just say, here's sale, here's margin, you might want to say margin is 10% of the sales number or whatever. Okay, so you just need to have that kind of different mindset. Okay, then you've got data scientists. So what we have with data scientists is, like I said, they are the sort of research people. Scientists is in the name, so they'll be doing a lot of hypothesis testing. So if you do any sort of subject that requires you to run experiments, then this is a really good job for you, because that's what you will be essentially doing. They'll be asking you hypothesis. If we changed the homepage from white to blue, would we get a bigger jump in sale or something? And you'll be building tests and stuff to do that. Again, experimentation is here. The other thing that data scientists do a lot of is build predictive models, whether that's to predict linear variables or categorical variables, but there'll be a lot of predictive modeling involved, a lot of feature engineering. Feature engineering is deriving additional information from data. So, for example, if you take date, okay, date as a data set, you might think, oh, it's just a date, but it's not. If the date, for example, today is the 5th of February 2026, we know that the day is a weekday. We know it's a Wednesday, a Thursday. We know it's February, the second month. There's lots of features you can extract from that one data point. Okay, if it's like it's 9:15 almost now, we know it's evening or nighttime. It's not daytime. We can extract a lot of features just from that one date variable. So you need to be very good at understanding and how to select and transform variables to extract features. And then finally, you need to be very good at storytelling. There's no point presenting a model back to the business. They won't understand it. You need to be able to explain the model very carefully. Data scientist CV, Python and SQL advanced, absolutely necessary. If you don't have advanced SQL and Python, then you're going to struggle being a data scientist. You need to have some machine learning ideas, especially around supervised machine learning. So things like regression, classification, tree-based models. Again, all of these things you can either do a course, or you should be, if you're doing computer science or some kind of engineering, you probably will do this, or mathematics, you will definitely do this kind of stuff. Again, like I said, you need to know how to run tests. You need to know about probability, okay? Because sometimes you'll be given, let's say, if you're detecting fraud, okay? Fraud is very rare, and therefore you need to know what's normal versus what's skewed, okay? So you need to have some idea of probability. Nowadays, you need to have some understanding of generative AI, how it works and how large language models work. Not that you'll be building anything, but if you use one of those large language models, you're able to explain it. ML ops and version control, basically what that means is that when you build models, okay, you don't want to just like throw away the data, the coding. You want to put it in what's called a repository, a GitHub. And so therefore, every time you make changes to your code, you can track it. So you can see what change you made to your code and what impact it had on the data. And then finally, you do need to do a bit of data ethics. You need to identify bias in your training data, because what you don't want to do is build a model that becomes an legal or ethical liability. The other one is machine learning engineer. Here, like I said, the models that data scientists will build, it's not necessarily that you would build those models, but you would deploy those models. You'd make them scalable. You'd monitor drift. Drift is when the model stops working, okay? So if I said, I'm going to build a model that predicts who's going to be a data engineer, okay? After a while, everybody who's predicted to be a data engineer will be a data engineer. There's no one else left to predict, okay? So the model will stop being accurate and it will drift. So they will do that. They do the infrastructure automation because you need to make sure that, whereas data scientists may do one-off extraction of the data, machine learning engineers will make sure there's a continuous feed of data to be able to do the models that, or execute on the models or apply the models. And then they need to know about APIs, because a lot of the data now is transferred through APIs. And your CV is, you need to be very good at, to be a machine learning, like it's very rare undergraduate degrees will get to this as an entry. You'd need to have a master's to do that, or you'd need to be very good at production Python advanced. Like this is like being able to be a programmer who can write applications. You need to be that good. C#, because a lot of high edge computing requires that kind of language. You need to be very good at APIs and web frameworks, and that basically means how do these applications work. So when you see a website like Netflix, how does it actually work? You need to understand how these work, because you can't deploy a model into a framework without understanding how that frameworks work. Containerization, again, not so important, but it is becoming common, where what they say is, look, when you build a model, we just want to deploy it. We don't want to like go off and rebuild it from scratch. So you would containerize it and then you just deploy it. So it's a bit like when you get a brand new laptop, you know, no one comes and installs Windows for you, codes Windows for you. Windows just installs. It's in a package. You load it and it just configures to the hardware and you get Windows going in there. So it's a similar principle there. You need to have a good understanding of neural network, at least at a foundational level. Okay, so CNNs, RNNs, that kind of stuff, transformers, that's the tech behind ChatGPT. You need to understand RAG now because of generative AI, and linear algebra and calculus is very important. So these are sort of the things that you sort of need to become a machine learning engineer. So those are some of the roles that you can go straight into into data from either undergraduate or switching career. Some of it, like I said, machine learning engineer, you might need a master's, or if you've got experience as a data scientist or something in software programmer, software developer, you might be able to walk into this. So let's talk salary. So what kind of salaries are we talking about here? So if you look at the builders, right, they, if you're coming at entry, they're quite high. Now, data architect is very rarely an entry level role, because you'd have to be an engineer or an analyst to move into data architect. But if you did like data analytics for a couple of years and you understood how it all worked, or machine learning engineer, you could move into a data architect role. You've got database admin. roles, like I said, we talked about just managing the database, and then analytics engineers. And you can see when you get to senior, you can go. So these like rank really high, and then they get quite good at the end. The interpreted analysis, that, like I said, the lowest, easiest role to get into is data analyst, which is reflected by the salary here. Okay, and then but after that, you've got statistician, and the reason statistician is quite low is because they're employed by governments or hospitals and stuff, or NHS. They're not, you're not going to get highly paid from that. BI analyst, again, very easy role to get into. Quant is very high, but you'd come from a top university with an engineering or a physics degree, or a computer science degree, and you're very good in the finance sector. And you can see the quants are very big, 200 plus bonus when you get to senior. The only problem is you're working like 18 hours a day, hardly getting any sleep, that kind of stuff, but you make good money. Data analysts and stuff, you can see there is a ceiling at the top level. You're not going to get beyond that ceiling. So, with the data analyst, once you've done it for a few years, that is sort of your ceiling. The AAML guys, so data scientist goes higher, ML engineer obviously much higher, and then the AI researcher, because AI researchers literally invent things that then is commercialized. So you can see, but their entry level is slightly higher, which generally means that you've either got a very good engineering or programming type degree, or you've got a master's. And then finally, sorry, this should not say the innovators, this should say the guardians, but data ethicists, governance managers, compliance. These roles, you can come in from policy type roles. So if you worked in local government, or you work in central government, or you work for organizations like think tank, where you have a policy type qualification, then you could actually come into these are not technical roles. These are roles where you're thinking about what are the rules and regulations that my company needs to stick to. Chief data officer obviously is a senior role. It goes right, it's one of the highest paid jobs in data, but you're at the board level now. You're at the top of that. Okay, so it's 9:20. We've got 10 minutes. So I'm just going to pause there, and if anyone's got any questions, feel free to just, if you could raise your hand. If you did that, I can then ask you to speak. Otherwise, just put it in the chat, and happy to answer it. Any questions from anyone? Anything you want clarification on? Oh, okay, someone's typing. If you want to contact me, there's my details. I'm also on social media, so especially on YouTube, I provide a lot of advice to people, who want to get into data. So follow my YouTube channel. Just type in Dr. Shawful, and you'll get the YouTube channel. Also on LinkedIn. If you're not on LinkedIn, get on LinkedIn and be professional. So Warda's question was, can we email the presentation? I'm hoping that's fine, Brother Tahir. If you've all given your email on the form, if you've all registered on the form, then Brother Tahir will have the email, and then I'm happy to send this presentation out via Brother Tahir. He'll email everyone. Okay, let's see other questions being. No problem, Shiraz. Thank you for attending. I hope you found the presentation useful. Tahir, do you want to ask anything?
Yeah, so quite a number of professions nowadays, they have some certifications which are available. Are there any certification that you could potentially recommend?
Yeah, so there's quite a few. So there's like certification from Google, there's IBM's, and even like Microsoft does a lot of certification around like Power BI, like SQL. They're given official names, so basically you can either learn with a partner, or you can just learn by yourself and then pay for the exam. And then the exam, you go into a center, or I think it's online, some of them, and you do it. So I can afterwards I'll try and research a few and send them to you. Okay.
So the certifications are aligned with the application vendors, as it were.
Yeah, so normally the vendors will provide a lot of the certification for that, but there are some generic ones, like the Google Data Professional Certification is a generic data analytics certification. There are some like machine learning and generative AI or AI researcher type certifications that you can do specifically for that. Yeah, you can go on platforms like Udemy, Coursera. They do offer courses, but like I said, this market's becoming very saturated because a lot of people are doing the Udemy, Coursera courses, which is great for your understanding, but they won't really stand you out when you apply for a job. What stands you out when you apply for a job is either your degree, really, or any experience that you have, or tool-specific certification, because then they know that if you've got a certification in a certain tool, you can come in from day one to do it. But obviously, that then narrows what you can apply for, because you can only apply for tool jobs that has that. So Mohammed's asked, how did I pivot from data to psychology? Basically, psychology is the analysis of human behavior, and we measure human behavior through data points, right? So when I was doing my PhD, I collected data on why children have accidents, and I was interested in analyzing data rather than doing surveys and asking people what they thought. I was interested in the data that systems collected. So early in my career, I worked in the NHS, and I would look at data that came from the hospital system. So when patients attended, what they attended with, who their GP was, any other conditions they had, and I would analyze that data to understand patterns and trends. And then when I went to the commercial sector, obviously there was data around people visiting websites, buying products, watching shows, especially when I was at ITV, watching different TV shows. And so we were collecting data about people. And so therefore it was much easier to analyze that data as a psychologist, much easier to analyze that data. And then obviously, as I went to analyze that data, I didn't know I was a data analyst. It's just that after a while, I discovered that's what the role was called. And then I built up my skills in coding. Statistics I was good at. I mean, I've got a PhD in psychology, so I knew advanced statistics, stuff that people now call machine learning. I was doing that way back 30 years ago. But it was more the coding that I picked up on the job. You don't have to be really good at it, because I sort of progressed up to just be sort of manage teams and run teams. I'm more of a strategic person in the data space rather than a coding person. Do any of these roles need to consider data security, i.e. cybersecurity point of view? So, so the machine learning engineer will definitely need to think about it, and the data engineer. The database administrator will also be doing that. What normally happens is that they will work with the tech team in order to ensure that the infrastructure as a whole is secure. So when you're working in cloud infrastructure, the tech team will generally take care of that. But if you are a machine learning engineer, for example, then you will be exposing data to websites, to apps, to point of sale system. So you would need to worry about how you expose that data so it can't be breached. How did you learn coding? Any insights and tips? The coding itself actually is quite easy to do if you do it day in, day out. It's like a language. You eventually get to learn it. But what's important is, can you solve the problem in your head? So what I mean by this is, if you want to learn coding, it's not the coding itself that's important, because if you do that day in, day out in a job, you become very good at it. It's how do you structure the query? So if someone asks you, can you tell me how many sales we had in December 2025 by males between 25 and 35? In your head, you've got to be able to structure that query. Once you've been able to structure that query in a nice, logical way, then you can just find what code you need to do it. But if you don't have the ability to structure the query in your head, so what we call analytical or critical thinking type skills, then you're going to find it very hard, even if you're brilliant at coding, because even in the software development space, the best software developers aren't necessarily the ones that are the best coders. They're the ones that can architect a solution. And so before you think about how do I just practice loads of coding, think about, can I structure the logic in a way that answers the question, and then learn the code to do that logic. Okay, Shiraz is just typing. Let's see.
Got a quick question. So currently everything is being influenced by AI. How do you see the influence of AI over this data profession? Because there's a fear that a lot of jobs are being taken over by the influence of AI.
Yeah, so a lot of these junior roles, like data analyst, business intelligence analyst, you can actually get an AI to write the code, and it will do it very well as a junior analyst. But like I said, it's the thinking. How do you structure the question, the answer in order to code it? That's what someone's still going to have to tell the generative AI model to do that. So your value is going to be coming in. How do you take a business problem and translate it into a query? Okay, and so that requires a lot of, like I said, analytical thinking, very structured thinking, being creative as well. Sometimes you get asked questions that haven't been solved, so you need to be very creative in how to do that. Like I said, writing code is very easy. Even like I said, if you go to Claude or Gemini, it will write code for you. It's very good at writing code. So don't obsess too much about learning the code. You can use, I mean, I used Google when I was early in my career. I didn't remember every code. I would just Google it and it would give me the code. But what was hard was how to structure the code in the first place. Okay. We just got a couple of minutes probably for one or two questions if anyone else has got anything.
Someone may ask a question about the domain knowledge. Obviously, someone entering fresh into this kind of work, they won't necessarily have the domain knowledge that they're entering into. But however, I'm sure that if they've been working beforehand, they may have certain industry knowledge.
Yeah, I mean,
Not
yeah, I mean, if you think about it, let's say you're going to go and work for a retailer like Tesco's, okay? The only thing you think in your head is, how do they make money? How does Tesco actually make money? Okay, and you've got to think about, like, why do they have a loyalty program? Why do they offer discounts? Why do they promote Coke over Pepsi? If you ask those questions, then you go and learn about them. And there's so many case studies out there on the internet. Okay, so if you're going to apply for a job where you are, let's say it's a hospital, right? You need to understand what is important to a hospital, right? What's different between an NHS hospital and an American hospital, right? It's very different. NHS hospital is about health outcomes, okay, and budget constraints. American hospitals is about insurance and minimizing damage and liability and all that. So you've got to have the mindset to be able to research the domain that you want to work in. Take broadcasters like television, like ITV, right? How does ITV make money? Through advertising. So there's no point going into ITV and saying don't do any adverts, because that's going to be stupid, right? ITV makes money through advertising. So you need to understand how a business makes money, and you need to understand how that money is then created. So through ads. Now, in order to deliver ads, what do you need? You need content. So who makes the content? Does ITV make the content? Does ITV buy the content? You've got to be asking those questions. Retailers, right? Again, go back to Tesco's. They buy products for a certain price, right? They sell it for a certain price. What they get is the profit, but then from that profit, they're paying on marketing, they're paying discounts, they're paying the loyalties, Tesco Club Card. So it's not enough to just say, oh, let's give 20% discount, everybody will come, because you probably make loss on it. So it's that kind of stuff that you need to be thinking about, or that if you want to build up domain knowledge. Okay. With modern AI and in-house Gen AI, do you see a future data roles of understanding on how to become a better prompt engineer, or is that not needed? So prompt engineering will be needed, especially if you're an analyst or a data role working with these Gen AIs. I mean, like, for example, my company, we're building actually an AI analyst. So you would prompt the analyst in human language, and it will create the query that you need to run on a database, right? So prompt engineering will become important, but you'll find it's going to be more important in product type data roles. So lease drop, which I talked about, extracts clauses from leases. Commercial leases. So prompt engineering is very important in that, because we need to make sure that the prompt extracts the relevant clause. It doesn't just extract any random clause. So prompt engineering will be useful if you're using a tool to do the end output. But again, even you'd want to master prompt engineering to create the code that you need as a data analyst anyway. So if you need to run a SQL query, you can just go to Claude and ask it for a SQL query. But if you're good at prompt engineering, then you'll get much better code to do that. Okay, brother T, I think we're over time. Shall we end the session there?
I think people have exhausted the questions as well. So I'm most grateful for your time. I personally found it very valuable and useful, and I hope that everyone attended also found it useful. I think especially the element of defining a job role and what should be in a CV was really key. And I think that gives people a starting point as to what they want to do and where they are at the moment and how far they need to go. Very beneficial. Thank you so much for that.
No problem. Absolutely. Okay, well, thank you, everyone. And I hope you found it useful. Like I said, I'll forward the presentation on to Brother Tahir, and if you've registered, then he'll send it to your email.
Sure. Thanks so much. Have a good night. Assalamu alaikum.
Alaikum salam.
Assalamu alaikum.
Alaikum salam.